Yeah. So what will happen is Zoom is recording it to the cloud. So even if I turn into a Cylon or get kicked off, it will continue to record. Hi, this is Brian from Let's Code Physics. I sat down with Brad Moser of Physics Alive and Hamilton College and Ann Leek of High Point University to talk about our reflections on the 2022 winter meeting of the American Association of Physics Teachers. In the 2 hours we spent recording, topics included quantum mechanics, board games, quantum mechanical board games, representation in physics, and what we hope to see in future AAPT meetings. I've split up this conversation into 6 bite-sized episodes that we hope you'll enjoy.
All right. Well, let's get started here. Good physics evening, everyone. I usually say good physics day, but it's 9:30 for us. 9:45, better than last night's 10:30. We are here to talk about the second day and now the end of the AAPT winter meeting from 2022. We are representing the East Coast right now, from Florida through North Carolina up to New York. So I am Brad Moser, assistant professor of instruction at Hamilton College, and the host of the Physics Alive podcast. And here with me are...
I'm Ann Leek. I'm an assistant professor at High Point University in North Carolina. And I'm actually hailing from the education department by way of physics.
And I'm Brian Lane. I am a visiting lecturer at the University of North Florida. I run the Let's Code Physics YouTube channel. So, Anne, we need to get you some media representation.
Sounds good. I think I've done one really awful, boring NPR piece back in the day.
Oh, nice. I will have to
go. On our local station.
Okay. I did that for the big eclipse a few years ago that went coast to coast, and that was the height of my local popularity.
Nice.
I got called in to talk about the LIGO experiment and the gravitational waves. Unbeknownst to me, they invited 2 people who actually do gravitational wave research. But according to folks who listened, I was the one of the 3 who could actually be understood by the lay audience. So I'll take that.
So the education coming through.
Mm-hmm.
Speaking of education, Anne, I wanted to ask you, you mentioned that you hail from an education department. You have as you described before we started recording, an oscillating background. What's your perspective of these AAPT meetings, either this one in particular or just the phenomenon in general of these people with usually pure physics backgrounds coming together to talk about teaching? What's that like for you coming from your world?
Well, I love it. First of all, I almost feel like I'm at this weird family reunion. Like you go and meet your crazy cousins and your uncles and aunts from all these different weird departments. So it kind of feels like a family reunion in a way, but it is definitely like, different groups coming together from physics, people who are in the trenches in the high school classrooms, all the way to like hardcore PER theory. And a lot of nuclear background. I don't know what it is about PER. I feel like there's like a condensed matter nuclear history involved.
Guilty.
Yeah.
Is it a field one wants to run away from, or?
I'll say for me, it is a trajectory informed by wanting to go get an advanced degree in physics, not knowing that PER is an option. And then finding that the discovery research is not quite as satisfying as you would have liked, and being a bit disappointed with the educational environment experience in that pure research world, and then wanting to go and make a difference in both cases.
Makes sense to me.
That's an N of 1. I mean, that would be if PER is allowed to study PER, it would be a great study. But that's.
I was just going to say it gave you lots of energy. But...
Super meta. Yikes.
Yeah.
All right, we're going deep here early on.
We can't not go deep. I mean, goodness gracious. The next item on our tentative agenda, and this is the way we did this last night, is just we had a roundtable of the sessions that we saw today. I've got my 20 tabs open to help me remember what I saw.
Ooh, okay.
I got my pages of notes.
Oh, you have your pages of notes. That's great.
I've got a digital notebook. We're good.
So maybe like yesterday, and now we have 3 plenaries that we can talk about, but we could start with the plenary about the James Webb Telescope and discussed by Matthew Greenhouse. So Anne, do you want to start us off? What were your thoughts on that?
Sure. It was actually really fun. First, I enjoyed the optics background that he gave on, the telescope and its construction. And he actually showed the launch video. It was like it covered all the bases from how, the origami folding of the mirror or unfolding of the mirror to exactly what they intend to study. Although, that's going to change a million times, but it can study some cool things. And, all the way to challenges that they think they might face and how they're dealing with some of it. And it's got a pretty wide range of what it can take images of from the sky. I think it was like 60% of the sky at any one time. And it can get pretty far away. And my favorite thing that they said they were going to do with it is take pictures of like oceans on Jupiter's moons. I don't know.
Yes. It's like, oh, there's flume clouds, or what's the word I want? Is it flume? Fume?
Yeah.
Anyway, clouds spitting up into the atmosphere.
Yeah.
It's like, that's great. It's like, if you can take pictures of that, that's cool. I thought the telescope was going to be looking like, I knew it was going to be looking deep in the universe. I didn't know it was going to be looking locally too.
Yeah.
So that was a cool new piece that I picked up from that. I wrote a little note on the side of my paper, and I was just like, the universe is so cool. It's just all the things they were talking about, looking for, and, being able to, searching for life by looking at the spectroscopic signature of the atmospheres of these planets that are transiting. It's just, you blink for a few seconds and all of a sudden we can study that much more new stuff. And it's just it's so cool.
And we get to see how planetary systems formed.
I could feel my blood pressure rising when he started going through the records of the getting it to the launch site. When he put up the map of it going through the was it the Suez Canal? The Panama Canal. There's 2 canals in the world, right? It had the map of it going through the Panama Canal. I could just feel my blood pressure going up, having followed the story on social media and seeing all of the Twitter astronomers saying, "Oh my goodness, we don't know where it is. Oh my goodness, it could be here. It could be here. Oh my goodness, they're not telling us anything." And them counting down the days and sometimes counting up the days as the launch got pushed back. It was a wild ride to relive, I feel like.
Well, and I think my new phrase in the classroom is now going to be one that Matthew used quite a number of times, which was, well, that's behind us now. And it went, well, we're done with that. That's what I'm going to be happy to say about kinematics and dynamics. That's behind us now. Now let's move on to something interesting, even though it was actually kinematics that drew me into physics in the first place. So while it's one of my least favorite topics now, it got me, it was my gateway in. So and there's that.
Well, it's the gateway, out of the atmosphere too. So, there's that.
Nice. Very nice.
So
I brought a comedian on.
I have a question. I don't know which of us is qualified to answer, but so James Webb is at the L2 Lagrange point, which I had forgotten is only stable this way going around. It's apparently unstable going toward or away from the sun-Earth axis. And so I was a little bit nervous about that. But I've heard of other spacecraft that we want to put at L2. And it kind of makes me wonder, well, how many things can we put there? Like pragmatically, how big is the equilibrium point there? And I don't know. I think that's something I need to research.
Well, considering that the James Webb Telescope is orbiting around that point, I suspect there's maybe quite a number of orbits you can, and space is pretty big.
Yeah,
I think.
And you don't want it right on that point from what he was saying, because there's some kind of thing with the shadow. I don't know. He was saying pretty near it, but not on it.
Mm-hmm.
We heard about, when I was an undergrad, we heard about the Lagrange points a lot because my professor at the time apparently had been a member of the L5 Society, which was like this big, like futurist society where they were going to build a space station at, I think it was at L2. or maybe it was at L1, and they were gonna have their first in-person meeting at a Lagrange Point space station.
Oh my God!
Like they entirely conduct before the internet. They conducted all this business over correspondence and periodicals and telephone calls, etc. And their first in-person meeting was going to be at a Lagrange Point.
Did we get invited?
I don't know. I mean, it depends on how big the space station is, I guess.
Do you have any reflections, Brian, that you wanted to share additionally before we jump into the many sessions that were there?
I will confess that I only caught the second half because I was playing chauffeur to the 3-year-old today, and I got in at the halfway mark. So
my wife took out the 3.5-year-old for the day, so I had the place to myself. The caveat was I was supposed to get some housework done. So as that talk was going on, I had wireless earphones in and I was vacuuming. And I was constantly running over to the computer to see what he was showing when it sounded like it was something really cool. Like, oh, I need to go see that. And then I would run to my piece of paper and it's like, I need to write that note down. And so it was an interesting experience. I think I'm ready for conferences to be live again.
Yeah.
So that
I
don't have duties.
Yesterday, I was folding laundry during several talks.
Yeah, that happened.
I'm with you on that.
I will be multitasking a lot less at my next in-person conference, even less than I was doing at my last in-person conference.
I'm worried I'm not going to make any of the sessions. I'm going to be too busy socializing in the hallway to actually open the door because I won't have seen or talked to.
Let's just make the next meeting the social hour. Like we don't need to rent any rooms. We just need a hotel and a hotel hallway. And we just bounce around the hotel hallway. That sounds good.
Sounds like
a food court. We need a food court.
Oh yeah, absolutely.
One of the coffee carts too.
Yeah.
Well, AAPT is looking for ideas about, boosting membership, and it sounds like we may be getting into that a little bit. So one of the ones I'll jump out with is, and this is an interesting conflagration, I think is the word, of events and people that last night when we were talking, Brian, you asked what would be a session in the future that I would be interested in. And I said, I want to know what are the types of careers that people are really going into in physics. And I want to learn more about those because I don't know anything about them. So one of the ones I saw on the docket for today was Anne's talk. I made sure I attended that one. Because I really wanted to hear about these ideas and what was it called? Shifting culture to support physics, innovation, and entrepreneurship curriculum. I learned a new acronym, PI. I didn't know that was an acronym. And it was one of my biggest note sections that I had written with so many ideas and places to look for information about careers and thinking about talking to, for my podcast, reaching out and talking to people in industry, and maybe Anne, you'll be able to give me some ideas of folks I could reach out to that I could talk to and say, here, this could be an episode for students to listen to this person describing how they use physics in their career. So I was really excited about that session. It's basically, I put my wish out and already it was there because I hadn't memorized the schedule yet. So I didn't know there were some sessions. So thank you. And that's partly why I ended up roping you in, because I enjoyed the talk so much and you had a great energy about you. And I thought you would be a lot of fun to talk to.
Well, thank you. I'm so excited to talk to you too. And I'm glad you enjoyed the talk. It's been really fun to learn more about physics careers and directions that students are actually going and want to go. It's not always that they're going to be physics professors, so it surprises some of the faculty in the group. But
I mean, it's the age-old question that students ask of, what am I going to do with the quadratic formula? Well, you're going to become a math teacher and teach people to use the quadratic formula. It's like, no, somebody has to go off of the academic branch at some point, right?
I thought that was how you got off this. When you're stranded on a desert island, didn't you need that equation? I don't know.
That would surprise me, but I would be happy to be surprised. If it gets me off the island, I'll gladly use it there.
No, but I mean, it's also very strange because students don't know that physics is preparing them for so many things.
Mm-hmm.
And yet when you ask employers, they would love to hire physicists. They don't often put physicists in the job call.
Yes.
It's not enough of us.
Yeah.
So they put like engineer or other relevant science.
Yeah.
and then
Yeah.
to the students to decide that they have the skill set to do that job. But we don't really show our students a lot of different career options. So I'm sure having someone on your podcast and really making it accessible would be a very valuable contribution to the physics community and showing students what they can do with their degree.
Yeah, the summary I heard a couple of years ago, and Anne, if this was in your talk, please cut me off.
Oh, go for it.
But the thing I heard a few years ago was that after interviewing lots and lots of employers, what AAPT found was that employers want graduates who can do two things, who want to have the experience of doing a deep dive into a subject matter, a technical subject, and the skill set to go and learn new subjects. And they don't really care what that first one is, as long as it goes deep and is technical. And physics is kind of one of the few majors that typically meets that requirement. And so it's not that you're going to go into a job and be solving Maxwell's equations one day and the Schrodinger equation the next. It's that you've done that difficult learning work and you know how to study and know how to go through a subject, so that when your employer says, okay, we need you to learn this thing about civil engineering today,
that's brand new that no one's ever done before. So you have to be the one that can handle learning something new that we don't know as a society yet. I think, yeah, definitely. And then the other thing is some of the smaller companies, I'll tell you the background on how I learned this through research sometime if you want to hear it. But some of the smaller companies that I've talked to, they say that they love physics majors because they solve problems across disciplines. And so if you have a team and you have people with very specialized engineering training or specialized material science training, you often need a physicist somewhere on the team to talk across them and to understand the foundation of all the other sciences that can really cross communicate and do the deep dive into a new area. So they're not afraid to learn something new, but they also can talk across different disciplines. Because a lot of times these companies are made up of teams, and at smaller companies, you have to wear different hats too.
Yeah.
So like, you're not just going to be doing one task. You have to be able to do multiple tasks with multiple people, talk to clients who have a whole different understanding. And physicists aren't really afraid to solve problems that are less familiar to them. All those late night problems that have to do something for us, right?
Yeah.
When you're taking a class in physics, the students are terrified of having to see a new problem, but that's part of what we have to help them overcome. That it's like, yeah, you have the basics, so you should be able to apply that to this new problem. But they're also, taking physics for the first time, and that's a hard ask. So
you gave me a basketball problem, and all you taught me were baseball problems.
That exactly.
So you're saying we should do all of those exercises left to the reader?
Yeah, maybe. The really open-ended ones with no definite answer.
Yeah. But anyway, let's not steal all the content from the episode I want to do by interviewing Anne. So we got to talk about some other things.